In this video, we will solidify our understanding of linear transformations by working through two examples where we have to determine if a given transformation is linear. Let's start here. So here's my transformation. When I plug in a vector x comma y, here's the new vector that comes out, 2x minus y, comma 3x minus 2y. If we want to see if this transformation is linear, we have to check both properties for linear transformations. Property 1, we have to look at the sum of two vectors. Here I have a vector x1, y1, and another vector x2, y2. In order to use the definition of this transformation, we have to begin by combining our two vectors. We add the two corresponding coordinates. So going up to the definition, we'll plug in x1 plus x2 for x, and y1 plus y2 for y, and this is what we get. Since we want to end up with the sum of two separate transformations, we have to begin separating out all of these terms. So what I did here was combined the x1 and y1 terms together, and then I grouped the x2 and y2 terms together here. And then I did the same thing in the second coordinate. Here's the x1 and y1, and here's the x2 and y2. And now we'll separate this out into two different vectors, t of x1, y1 plus t of x2, y2. So here's the first coordinate from this. Here's the second coordinate from the first one. And then here's the first coordinate from our second term. And here's the second coordinate from the second term. So that completes the first property. So next we need to see if we can factor out this scalar. But in order to use our definition again, we have to multiply through. So each coordinate, each element gets multiplied by c. And then we plug this into the definition of our transformation. So we have 2 times the first coordinate minus the second coordinate, plus 3 times the first coordinate minus 2 times the second coordinate. But since everything is being multiplied by c, we know that we can just factor it out of this vector. So this is really c times 2x minus y, comma 3x minus 2y. But this here is our function. It's what comes out of the function. It's t of x comma y. So that property also checks out. So to answer this question, is the transformation linear? Yes, this one is. Let's move on to the second example. We have a new transformation. T of x comma y is now going to be x squared, y squared, and we still want to find out if this transformation is linear or not. Before we get started, you might want to pay attention here. The first coordinate is being squared, and the second coordinate is also being squared. Is squaring really a linear operation? Well, let's check the second property and see if it is. If this is linear, then this c, the scalar, should factor out to the front. So begin by multiplying through. You get cx comma cy. And then use the definition of this transformation. We square the first coordinate and the second coordinate. So this becomes c squared x squared, comma c squared y squared. And that c squared, since it shows up on both elements of our vector, can be pulled out to the front. So if this was going to be linear, remember, this should be a c. But in reality, we got a c squared. So this transformation is not linear. So from these two examples, you should gain a little bit of intuition. In the first example, our transformation looked linear. In our second example, our transformation looks quadratic. So keep those differences in mind as you're working through your homework.